Hey guys, so this lesson that we're going to be taking a look at first is relations and functions, lesson number 3. We're going to take a look at the x and y intercepts and interpreting the relations. So, like it says, we already learned this when we did the first two lessons. A relation is a connection between two quantities. A relation can be represented graphically by a set of ordered pairs, which we sometimes refer to as coordinates. The first component of a set of ordered pairs is going to be the x-coordinate, also known as the input. Values in this are part of the independent variable. The second set is going to be represented by y, and that is part of the dependent. So, when we're taking a look at the x and the y intercepts, for all these cases, we can see if we're listing the points or coordinates where each crosses the x-axis, that's going to be crossing the horizontal axis here, and I can just state this function is going to cross right at this point, which happens to be at -3 and 0. I can see for the second one, it actually crosses twice. I have once where it crosses here and once where it crosses over here. The first one is at -2 and 0, and the second one is at +3 and 0. For the last one, for the circle, it crosses on the left-hand side and the right-hand side once again, once at -4 and 0, and once at +4 and 0. What do all the points have in common? Well, for any of these points where it crosses the x-axis, y is always equal to 0. If I'm looking at the y-axis where it crosses, well, I can see for the first one, it crosses up here at the point of 0 and 5. In the second case, it crosses right up here at the point of 0 and 6. And in the last case, it crosses once on the top, once on the bottom. The top one is going to be at 0 and 4, and the bottom is going to be at 0 and -4. Whenever it crosses the y-axis, what does it always have in common? X is always equal to 0. Taking a look at the second page here, it talks about the x-intercept is the x-coordinate of the ordered pair where the graph intersects the x-axis, like we saw with those first examples. An x-intercept is always going to occur when y is 0. So the instant that I see x-intercept, I always think y is 0. The y-intercept is when it crosses the y-axis. The y-intercept is always going to occur when x is equal to 0. So if I'm looking for the x-intercept, it's y is equal to 0. If I'm looking for y-intercept, it's x equals 0. I can always solve this algebraically by saying, well, if I want x-intercept, I'm just going to change y to 0 and solve for x. Inversely, if I want the y-intercept, I'm going to set x as 0 and solve for y. So if I'm taking this first class example, the equation 1 on the previous page has a graph where it is 3y is equal to 5x plus 15. If I'm algebraically determining the value of the x-intercept, it means I'm not graphing it, I'm just going to replace the values. If it's the x-intercept, like I said, y is equal to 0. So I'm going to state that 3 times 0 is going to equal 5x plus 15. 3 times 0 is just going to be 0, which is equal to 5x plus 15. And then I just need to solve for x. So I'm going to subtract 15 from both sides. -15 is equal to 5x. And I'm going to divide both sides by 5. -3 is equal to x. That's the same as the solution we got, where it was -3 and 0. If I'm doing the y-intercept, then I'm going to state that x is equal to 0. So in this case, 3y is equal to 5 times 0. plus 15. 3y is equal to, well, 5 times 0 is still just 0. So that is going to cancel out, which means that when I divide both sides by 3, y is going to equal 5, which once again was a solution we had on the other page, 0 and 5. If I'm looking at the second set, well, for that circle, it's going to be x squared plus y squared is equal to 16. When I'm calculating the x-intercept and the y-intercept, I'm still doing the same process. X-intercept is y is equal to 0. Y-intercept is x is equal to 0. When I'm solving for the x-intercept, if x squared plus 0 squared is equal to 16, then x squared would equal 16. Now I know that if I have a number squared and it equals 16, there's two possibilities. I could either say to have a number squared and get 16, it could either be 4 times 4 or negative 4 times negative 4, which means that I'm going to state that x is going to equal the positive or negative square root of 16, because it could be the positive times the positive or the negative times the negative, which means that x is either going to equal positive 4 or negative 4, which is what we found on the last case. Same when I do the y-intercept. If 0 squared plus y squared is equal to 16, it's going to be the same case. Y squared is equal to 16, where y is going to equal positive or negative square root of 16, which means y is equal to either positive 4 or negative 4. If we're looking at the last part here, it says Lisa purchases a new car for $20,000. The value of the car can be represented by the formula. The value is equal to 20,000 minus 1250t, where V is the value of the car in dollars, and t is the age of the car in years. We can see, based on what they've done on the graph here, that t is going to be my independent variable, and v is going to be my dependent variable. It's the same thing with the chart. The independent goes on the left, the dependent goes on the right. So I can always solve for what these things are by replacing the t value with whatever it says. For the first one, it says it wants me to replace it with 0. So I can say v is equal to 20,000 minus 1250 times 0. I can put that in my calculator, and I'm going to see that v is equal to 20,000, which means that the ordered pair I'm going to get from this is 0 and 20,000. And I can plot that point on my graph, 0 and 20,000. When I go to the second point, I'm going to replace t with 2, and in this case, I'm going to get 17,500 when I put it in my calculator, or 2 and 17,500. And then I'm going to find that point. I go to 2, I go to 17,500, and I graph out this point here. Keep going. If I said that it's going to be 4, when I replace 4 where t is, I'm going to get 15,000, and I get 4 and 15,000. Graph that out, and we can already see this straight line forming. And the last point that it wants us to graph out for here is going to be 6. When I replace 6, it's going to be 12,500. And I'm going to graph that point right here. When I connect the points and stretch them out, sorry, I'm going to try and do this as accurately as I can. And actually, to make my life easier, I'm going to draw in a few more points that are going to stretch out in the same pattern. Just to make it a little bit more accurate. If you want, you can just do the same thing with a ruler so that you can draw it as clearly as possible. So it's always doing the same pattern. In this case, you can see it's going down 5 lines and right 2 lines every single time. When it asks, what does the ordered pair of 0 and 20,000 represent? Well, in the case, it is when 0 time has passed, the car is worth $20,000. If I'm using the graph to estimate the t-intercept, well, the t-intercept that I can see here down at this point looks like it is 16. It represents after 16 years, the car has no value. If I'm using the graph to estimate the value of the car after, say, 3 years, then I'm going to follow along the x-axis here, or t-axis as the case may be, until I get to 3 years. I'm going to follow straight up from there, and I'm going to get the point that exists in here. Now I can see that it's somewhere between the 16,000 and the 16,500. So let's say that for this case, it's approximately 16,250. When I go for the 10 years, then I'm going to follow straight up from the 10 years. This looks like it's a clear point that exists on here, and I'm going to say that's about 7,500. And when I go for my 14 years, I'm going to follow along to 14, come up here, and it looks like it's about here, where at this point it looks like it's 2,500. If I'm using the original formula that I have up at the top here to verify the second case, or the 10 years, then I'm going to say that V is equal to 20,000 minus 1250 times 10. When I put that in my calculator, I get 7,500, which matches the information that we had. If I'm using the graph to estimate what the car will be, or sorry, when the car will be worth $5,000, in this case, I'm going to, instead of following along the horizontal axis, I'm going to follow along the vertical axis. And I'm going to say, well, I'm going to go up the vertical axis here till it gets to 5,000. I'm going to come across, and then I look here, and it looks like it's going to be after 12 years. If I want half of the purchase price, well, half of the 20,000 is I'm looking for when it's worth $10,000. At $10,000, I can follow up here, come across, and it looks like that's going to occur after 8 years. That would stand to reason with what we found here, where we said that when it went from its full value of $20,000 to its value of $0, took 16 years. To get half the value, it would logically take half that time. If I'm using the formula to verify this, I'm going to say V is equal to 20,000 minus 1250 times 8, which in this case is going to be $10,000. And that matches the information that we had as well. So if I'm completing this statement to describe the relation, the original value of the car is $20,000. It depreciates in the value of $1,250 per year and has no value after 16 years. So go ahead, try some of the practice questions and let me know if you need any help.